Okay, the next topic is rate of change. And this is a big thing. This is one of the really the big topics of calculus, or rate of change. So we're going to introduce it now. And a rate of change really just describes how an output is changing with respect to how the input changes. So we have a function with an input that's changing, and that causes the output to change, and we want to describe that that relative rate of change. The first thing is we want the average rate of change. So here's the function, y equals f of x, and we have two input values, x1 and x2, and we want to see how much does the input change and how much does the output change, and it's the ratio. And change is, that's the difference. If you want to know how much the input changes, you'll subtract the new, take away the old value from the new value. And likewise, we'll take away the old y value from the new y value. That's just the average rate of change. And one place you see that is with slope, that if you graph a function, here's the x-axis, and there's two input values, x1 and x2, and those cause two output values, y1 and y2, and those correspond to these points. And we want to know how much the x value changes. That's just going from x1 to x2. And we want to know how much does the y value change, because we're going from y1 to y2, and we'll just take that ratio. The slope is delta y over delta x. And there's a lot of examples of rates of change. We just saw slope, but population growth is a change because the population is changing with respect to time. Speed, the distance you've traveled, is changing with respect to time, and so on. So there's a lot of examples, and the mathematics is the same for all of them. Let's do some problems. So first, let's look at the average rate of change of the function x squared when x changes from 1 to 5. So I'll graph this. Here's a quick graph, and we're going to plot this function as a parabola. It goes like this. And we have two x values. Let's put it over here, 1 and 5. And the corresponding y values are 1. So here's that point, 1 comma 1. And the output for 5 is 25. And so we just need to compute the delta x. Delta x is 5 minus 1, or 4. And delta y is 25 minus 1, or 24. And that'll let us compute the average rate of change that connects the one point from the other. We usually call it m, but it's just a rate of change, delta y over delta x. That's 24 over 4, and that is the answer, unless you love to simplify, and then here's another correct answer. Let's do the next one. Again, I'll draw a picture. 1 over x looks like this. It decreases, and we have 2 points. We have x is 1 and x is 3. And so I can already see that delta x is 3 minus 1, which is 2. Let's get the y values. So over here, 1 over 1 is 1, so the y value is 1, and this point is 1 comma 1. And over here, 1 over third is the y value, so if I put in 3, I get 1/3, and the y value is 1/3. And over here you can compute delta y. That's going to be the new y value, 1/3, minus the old one, 1, and the answer is going to be a negative number. That's negative 2/3. So the rate of change, delta y over delta x, is negative 2/3 over 2, and that simplifies to negative 1/3. Okay? I did some work with fractions. If you're having trouble with fractions, that's a good reason to make an appointment with the tutor. Let's do something more abstract. We're going to have a more complicated x2. It has a variable in it, a parameter h. And so what this means is that x2 value is changing, and we could set up a picture, a quick picture, like this. We have 2 points over here, 1 and 1 plus h. And this just means that h is moving. We think of h as a small number, maybe getting close to 0. And so we're sliding this point along the curve. And that's actually a technique in calculus to compute the instantaneous rate of change, which is the slope of the curve at that point. But we can do it algebraically. We want just delta y over delta x. And delta x is the new x value minus the old x value. And delta y is the new x value, that's 1 plus h squared, minus the old y value, which is 1 squared. And we should simplify this. It actually does simplify. 1 plus h quantity squared is 1 plus 2h plus h squared. That's a binomial. If you forget how to do that, make an appointment with the teacher, with the instructor, or with me. And in the denominator, the 1's cancel, we just have h. But notice that those 1's cancel. And in the numerator, the 1's cancel as well. And this is actually kind of nice, a lot of cancellation. We have a 2h plus h squared over h. And there's a common factor in the numerator is h times 2 plus h over h. And that's a factor, so that cancels, and we're left with 2 plus h over 1, which is just 2 plus h. I'll write that up here and put a box around it here. But let's do one more problem, a little bit more complicated, with 1 over x. And strategy may be this. X1, Y1, and X2, Y2. It might be good to just write that out. We can see that X1 is 2, that's given over here, and X2 is 2 plus h, that's also given, and Y1, we'll use the formula 1 over 2, and for Y2, the formula 1 over 2 plus h, and delta y over delta x, I'll draw a line down the middle here, delta y over delta x is going to be the new value, 1 over 2 plus h, minus the old value, 1 over 2, divided by the new value, 2 plus h, minus 2. And it's never a bad idea to have parentheses if you want to use that. If you don't use parentheses and don't make mistakes, then you don't need them. But the more parentheses, the more accurate. And one task that we have is to simplify this. But I will leave that up to you. In some cases, we do want to simplify this. And definitely when we get to calculus, we want to simplify this. And it does actually simplify nicely. But I'm going to stop the video here and see you next week.